Hey guys, how's it going? Welcome to another episode of Ferris Makes Emulators. This is episode 40, by the way. So that's actually crazy. Yet, it's the 16th bug squashing episode, so still working on these same bugs. We're definitely getting closer. However, at the end of the last episode, it looks like we found some issues in the test ROM we made, so we're going to actually start by hopefully debugging that. Unfortunately, it was only bugging on the hardware, so we got to do some thinking and some probably slow and tedious debugging. But when we figure that out and we know it's correct, that'll just mean we can trust the information more and hopefully make better decisions based on that information. By the way, if you guys like the music that I played before starting streaming, this was a demo called K9V Orange Main Sequence, which came out last weekend at datastorm. It's by the group Ferris. It's a really good demo. I actually feel like watching it again. I really like this demo. Let's do that. Hold on, let me make sure my stuff works. Yeah, so I was at datastorm this last weekend. Super fun party. Mostly an old school Amiga and C64 party. Really, really fun. Spent a lot of the time sitting next to Blueberry while he worked on his 4K. That was a lot of fun. Met a lot of people. Some I knew before, some I didn't. It was just a good time. Definitely going to go next year because it's super easy to get to from Oslo. So it's super easy to get to, nice and comfortable. Really fun party. This was the winning demo, by the way. I don't know if this is a 50 FPS version. Even if it is, I may not be recording with the right frame rate, so it may look a bit sketchy, but yeah. Fairlight does a lot of these animation-based effects that are really, really nice. I kept saying that to Pantaloon that they do a lot of those, and I meant to say that they do a lot of really good ones. Like, I really like the ones that they do. And that I think they're really cool. I hope it didn't sound like I was just giving him shit, because I totally didn't mean that. I love their stuff. And he was super nice at the party. So yeah, I had a great time. Yeah, Colin says it's okay to give him shit. But I actually don't mean to, because I just really like it when they do that stuff. They do a lot of really good effects like that. Yeah, the music was really good. The part after this has a snare drum that just, oh, it's so nice, so nice. Tasty is the word. Right there. That's a great snare. I think it's, of a lot of the tunes that Viklund has done, who did the music for this, it's one of the more straightforward tunes that I've heard from him. But it's also one of my favorites. I think it's just super solid, super focused, just a fun track for a fun, quick demo. At least quick by C64 standards. Anyway. Super fun. By the way, hi to guys in the chat. Alkama, Duro2. Do I say that right? Duro2? Anyway. Daniel Collin, Garrett Kelly, Cluwash, Wistertube, Dark Second, and Tomix. Tomix, I would be impressed if this was done in HTML5. I don't know how these people do this with C64. I hope to actually do a bunch of that on the Sunday streams, because I've been thinking about some more effects. Some I want to do in 4K, and I want to keep some of those secret, but some I just want to do because I think they're cool, and I want to like figure out how a lot of the data will work. So I may just implement a lot of that stuff just for fun. Hold on. I'm bugging. I had a small release, by the way. I'm actually going to play this. It's also pretty quick. We won't play the whole thing. But I had a small release at datastorm. And I'm bugging. Oh, he says Daru. I guess that makes sense. Just a little running in the emulator here of the small entry I did. This was a collaboration with Pegboard Nerds, Alex in particular, and it reminded me as I was texting him because I'm bugging him about getting me some source files so I can release the source. But he did this really cool pendulum cover and also this sort of graphic cover of the album artwork, and I did a little scroller for it. I'm happy with the scroller, actually. It was a little bit of tech porn. A little bit harder tricks to actually make that display like this. Hey, local hoster. The Origins of Ferris, I had a different handle before that sounds really stupid. And I was looking for a new one, and I happened to watch the movie Ferris Bueller's Day Off, and I was like, oh, I like the sound of Ferris. So I just took that. That was it. Must have been 15 or so. Been using the same handle since. You'll often see me as Yep Ferris on stuff, like Steam or whatever. And that's because I was in a demo group called Youth Uprising. So Yup is short for Youth Uprising. So it's Yep Ferris. And that's like never taken on stuff, so I'm often that handle on different things. Anyway, basically seen most of what that does. You guys can check that out if you're interested. But yeah, enough about Datastorm. We'll talk more about that on Sunday, actually, because I do actually want to do at least a bit of a breakdown on the harder tricks I used in that scroller, because there's actually some kind of interesting stuff there. Especially if I can release the source by then, that'd be nice. But anyway, on to emulator stuff. So particularly what happened is we got this thing that could capture... whoops, that's too much. Thing that could capture basically the different bits of a register over time, in particular over these frames. Some data that looked really good, particularly this display status and the inner pending. The stuff here looks like it makes sense. But when we captured the drawing status, things got a little weird. If I do this in the emulator, it also looks fairly sane. And that's... yeah, that's in like all the emulators that I tried. However, when we run it on hardware, the data doesn't look like it makes that much sense. And at the bottom here, we get like another bar of graphics drawn, and I really don't know why. So I think we'll just start by looking at the test ROM code and just kind of seeing if we can massage that until it maybe makes sense. Bit annoying to start with that, but I think that'll be okay. And then if we can get this to kind of still make sense in the emulators, but then also look good on the hardware, then we'll do at least run this again for the other registers. And when that looks good, then we'll actually see if we can get the right data, because we really should see like the top one and the bottom one. We see some definite correlations here. Like this is when the left frame buffer is being displayed to the right one. And these, you'll notice these lines here are a little bit darker, and that's because they actually flicker. Because like on alternating frames, we'll have either the left or right one being displayed from frame buffer 0 or frame buffer 1. And so these kind of flip back and forth. And that totally matches up with the sort of timing that we would have expected, because we would have expected that to take about a quarter of a frame. And with the exception that the pulses here are a little bit offset from what I would have expected, it looks really nice. And yeah, totally matches with what we would expect. They also jitter in the right way. And they're also correlated with these, the left display finish and the right display finish bits down here, which totally makes sense. So this top one and this bottom one look really good. But this middle one doesn't, and not entirely sure why. It's also weird too because we have it separated so that we're doing like one pass. Like we have the hardware set up to do drawing every other frame, so we let it draw stuff, and then on the alternating frames, like as it's drawing, we're just capturing stuff, and then on the alternate frames, we actually write the stuff we captured. We sort of do our own software drawing into the data into VRAM, and then it will draw from that again. So it's this little sort of feedback loop, but it should basically stabilize. And again, something is weird with this middle one, at least. I'm hoping it doesn't totally ruin the data from our others. I don't think it will. But yeah, that's where we're at. So I just want to look at, where's our VBDE here? I'm just going to go through the code, like basically line by line, remove some of this stuff as well. These are the indices for the bits that we were looking at. I'm also going to pull up the documentation, check that out. It's going to feel so good to fix this bug, you guys. I really cannot mention that enough. By the way, in case I forget later, I actually have a small streaming announcement. Tomorrow, during office hours CEST sometime, it looks like I'm doing some shader-related stuff for work these days, and I made something kind of cool in Fuse that's very shader toy-like in order to work on this other shader stuff a little more effectively. And it looks like I may be able to stream some of that while working on it during my work hours. So I would be doing that from the Fuse office, which is pretty rad. I don't know when that's going to be yet because there's still some setup stuff, and I got to kind of work it into the other work that I have to do tomorrow. But yeah, we're going to try that out, see how that goes. Maybe we won't in case I don't get it ready, but yeah. I'll keep you guys posted on Twitter as to when that is, if it happens. So just a quick heads up there. While I get this document here. So particularly we are looking at the drawing status, which is here. So we wanted bits 15, 12 through 8, 4, 3, 2, 1. And we should see exactly that. 15, 12 through 8, 4, 3, 2, 1. Exactly the bits we wanted to see. We have max 1,000 entries, so this thing is basically allowed to change 1,000 times. I think we're going to hit a bottleneck that this will not end up working if there's too many entries or whatever. We don't really have a way to detect that currently. I guess we could actually try and detect that. I could change the background color to, I guess it would be, if you change this to 3, we should get basically solid red as the background. Yeah, so it'd be like this. I could actually do that, like detect if we write out too many of these. I think I might do that actually, just to sort of add to this. We know the first one's not going to do this, so we can actually skip it on the first one, but the capture loop, we want to do this. It's here. That's what we're gonna work on now, Daru. Figure out why there's that extra row. It only happens on the hardware, but so I mean, so here already we're gonna see that this seems to scan not quite the same value over and over again, but scans out this Y position stuff here in this emulator. And yeah, do this just to rule this out actually. I might just run this on the hardware just to see if this happens. If I get a solid red screen, then we've actually captured too many entries. And we could increase that number, but my gut feeling is that we're going to have other problems if it gets that high anyway. In fact, I actually could drop the max because I just kind of picked a high number anyway. I even doubt it would be 100 different state changes that we would get through here, but I could be wrong. So that's 100, and it seems to be okay in the different emulators. I'm actually going to run this on the hardware. Methinks. By the way, I ordered a 4th Virtual Boy. And I can explain why, actually. Drew, I think you just saw Atari ET in your emu's output. That's exactly what it looks like. Hey, Metal Voids. So the reason I bought a 4th Virtual Boy is because I'm part of a group that's like discounted Japanese import stuff. And they had a deal that was $200 for a Virtual Boy and Mario Clash. Now, Mario Clash is a somewhat rare game. So $200 for another Virtual Boy and that game was totally worth it to me. So I went ahead and ordered that. As I want a couple more of these, especially if I end up hacking together some kind of display solution based on like taping webcams together or something. That would be a good temp solution before I could do some FPGA based proper one, which I probably wouldn't do for like a year or something. But anyway. So I picked that up. It's gonna arrive here in a few weeks probably. No, it doesn't have VGA output. Hey, Studio C. Would be fun to build something like that eventually, though. I did actually talk to someone at datastorm about some FPGA stuff. And it was cool because he kind of filled me in on some timing things that I was always worried about and basically told me exactly how to get around them. So kind of want to try that stuff even more now. There were just some things I was confused about that he totally cleared up. Basically how I should divide clocks without metastability problems. Ooh, nice Dark Second. Capitalism indeed. It has its good sides. Possibly outweighed by its negatives, but you know, that's another discussion. Yeah, MX, that makes more sense. Like those clicky blues. Ha! Okay. Bright red screen. So it had that extra bar again. And then it's sort of filled up. And then it just went straight red. So somehow we overflowed this. Not entirely sure how that could have happened. But that's what we'll look into next. So something's wrong here. At least we have some kind of clue. So that's good. Hey, Level XMTex. Again, I think this is going to be a fine number of max entries. We'll try and clean up the logic, and then if it still goes red, we'll see if we can increase this to some reasonable amount. But anyway, so I have game frame index is 0. Do I use that anywhere? I don't think I use that for this. But is it just increased and then that's it? Yeah, let's get rid of that. So I don't think we're using that for anything. I think that I was using that for the test rendering stuff, like when I was just drawing basic patterns. I think that was what that was for. That would make sense. By the way, totally using MNAF in here because it's easier to just click that button than to build it and then test in my emulator. And that's fine because we just need a rough idea of how this is working. So yeah, we set up the column table, normal stuff. I'm pretty sure this display setup is quite correct because all we really do is we set up the... I don't remember what this is actually. We basically set up the drawing control to be really basic. Actually, we do the drawing status or drawing enable. Oh yeah, we just read it and enable the drawing enable bit. That makes sense. For display, we'll do the same thing, but we enable sync. Jess Wheeler 92, thanks for the follow. RE, I'm not sure if that was reset. Can't remember. And then display enable. Frame cyc is 1. This is, again, the period of frames that it does game frames in, which is basically how often it renders. 0 would be every frame. 1 is every other frame, which is exactly what we want, because we're going to have it draw one frame and then capture all the stuff, and then we're going to actually render our results in the other frame. So that should make sense. Honestly, though, I could bump that up just to give us some extra time to render stuff. But again, I don't think that that's where the problem is. But if that is where the problem is, we could do that. Because if we got like out of sync with the hardware or something, that might be a problem. But I doubt it, because I think the states we wait for actually makes sense. But we'll have to see. And then we clear all the interrupts. And then we wait for 3C on these bits, which again, I just wrote wait for VBlank probably. Other startup code had this. I think this is going to be good enough. Then we just write out all these color things. This is the brightness registers. And then here's our palette registers here. And then I think these are world palettes and sprite palettes or something. And then just setting the background color to 0, which will make it black. It doesn't actually clear any of the memory on the screen data. Maybe that's a problem. We'll have to see. We set up one world, because this is all we actually need to draw into. We just need a main world, which is going to be active on the left and right screens. I don't remember what this is. But then we set its width and height to the full screen. And we set the next world, which is going to be a dummy world with the end stuff. So this is going to be correct. We're going to copy our char data into this character segment. 4 characters here, and that's all we have here. Our different lines. So that makes total sense. In order to make this a little clearer, by the way, don't remember who suggested this last time, but could make the ones that represent 1 a little bit shorter. Might make it more clear, so I do want to give that a shot, actually. That would have been the solid here, I think. That's what we wanted. Or no, bottom line and top line is what we want here. Yeah, so I think I just have the top one be 0. If I just change this one to 0 and this one to 0, then that should make some kind of sense. And the build failed because periodically with this tool we have to clear delete the build directory, which is fine. I'm just going to do that quick here. Oh, by the way, I totally forgot to publish last week's emulator episode on YouTube. I guess that's not going to make much of a difference for you guys watching live. But yeah. Totally going to publish both tomorrow, probably. That's exactly it, alkama. Actually, I totally didn't look at what I wanted to look at. Yeah. So I think this is still pretty readable. Let's leave it like this. There's no problem. That'll definitely help when I'm taking pictures, phone pictures of the output of the Virtual Boy. So I think this will be okay. Yeah, this format for the entry I think is still going to be fine. This timestamp thing might actually be somewhat interesting. Word is going to be 32 bits though, so I highly doubt that's going to cause us any problems. And then the value is correct because we're only ever reading 16-bit registers here. So I think that's going to be fine. Yeah. Okay, so we copy this stuff. Oh, here I clear the background map data. Good. So I do clear this. This is very good. So this should actually clear the entire map. All 64 by 64 tiles of the entire map there. That should be good. And then we set up the display, which this already does this somewhere else. Up here. But I guess it wouldn't hurt to just do this again, so that should be fine. We don't need the VIP interrupt here. or to set the interrupt level because we're not doing that. And we do want to reset the pending interrupts. And I just set all the bits because I don't think that hurts. I mean, we could do the interrupt pending stuff like this. Why not? You can do that here too. But then we have our main loop. And here we have num entries, and we set that to 0 before we ever use it. So I'd be surprised if that causes problems. So yeah, so here we wait, particularly ooh, wait a minute. Oh no, okay. So here I reset the pending interrupts. It's important that I do it there. We could do it both of these though. I think that might be smart. Reset pending interrupts here, and then we wait until we get game start and frame start. And yeah, I think this here makes sense. Once we get that, then we're going to reset all the pending registers, or all the pending interrupts here. And then, yeah, then we grab the initial register value, which is going to be our drawing status. Total ticks is basically reset our time scale. Previous register value is the current one, which is what we grab here. Entry pointer is the start of our entry table. And our num entries is 0, so this looks good. And then we're going to add our first value. So what we do here is we just set this pointer to the start of our entry table, and then that will just point to the first one. And then we just set the timestamp and value on that one, and then increase the pointer, which will make it point to the next one, and then increase the num entries. So this looks good to me. And yeah, incrementing a pointer will increment it based on the size of the thing that it points to. So that should make sense. So that's us waiting to start capture, and then we reset all the capture state as well as capturing the initial value. After that, we're going to loop until we get the frame start interrupt again. And this is when we get it again, because we wait till the frame start and the game start. And then we're going to capture until we just get frame start again after clearing that frame start state. So that should make sense. So here, we're going to grab the interrupt pending register value, which we only really do because we're going to check this down here until the start of the next frame. Let's actually... It doesn't look like we actually need this in this case. So let's actually move this like this. I think that makes a little more sense. So we're going to grab the value we care about, see if it's different than the previous value, which should be equal to the initial value here. If it is different, we have our error condition here, which still adds the entries, by the way. Maybe we should... go ahead and break this. Hey, if note. But yeah, if they do match, we have this error condition, which shouldn't actually happen, but for some reason it might. Yeah, exactly, bad moves. Entry pointer, yeah, then we set it the next one. We set this to the total ticks, which we do up here too. Here we could use 0, but I like to make this consistent. So yeah, so we set it to whatever our ticks was, and then we're going to set the value and then increment our pointers here. And then we're going to say the previous value is the current value, and then we're going to increment our ticks. So the ticks is just how fast we go in this loop. So it may actually, if we end up capturing a lot of different values here, the total ticks will actually sort of change in scale, but it should be to a small enough degree that it's not going to matter. So I think this makes sense. And then when we get the frame start, then we're going to actually start rendering everything. So we have a bit index here, and I loop through all the 10 different bits that we have that we care about. I'm just going to count those again. Here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And yeah, so for each bit, because we're going to render each bit as a different row. No, if not, we actually started this ourselves, trying to capture some information from the hardware so that we can actually change our emulator to have better video hardware timing based on whatever the actual hardware shows. Yes, so for each bit, we render a row. So for example, it will look like this. So for each bit we're watching, we render a whole row. And particularly, yeah, so I say the row pointer is the map pointer. Wait a minute. Oh yeah, okay. So yeah, so I have this map pointer here that starts here, and then I have the row that points to the current row. This is actually... Okay, I think this actually makes somewhat sense. Actually, I kind of want to do this. All the row pointers here. We can do char pointers. And then the map pointers here I want to call row pointer. So it's basically the row pointer starts there, and then we'll have a char pointer that goes off in front of that, and then we'll increment the row pointer. I think that makes a little more sense because it's pointing at one of the rows in the map. So we start by setting it to the top left corner of the map. We say the char pointer is that. We also have the segment start, which is we're going to render this in a bunch of different segments. Each different unique value is a segment. And what we do is we go through all the entries. And actually, interestingly enough, this might actually render far beyond this because each segment is always going to be at least one thing here. Theoretically, if that rendered... Oh, wait a minute. 3, 4, 5, 6, 7, 8, 9, 10, right? Okay, never mind. This is 10, so this is actually the correct amount of these. I was just thinking, like, if we had too many values, this could actually wrap around there. But I don't think it will. It would have to go pretty far for it to do that. Anyway. So, for all the entries, this would include the first one. We basically have the start of the segment. So we grab the next stuff for the entry. We basically grab when the next entry would start. If it's the last one, we put it at 47, which is basically the last space minus 1, last available space on the screen. Or otherwise, we're going to take its timestamp, cast that to a float, divide that by the total ticks cast to a float, and we're going to multiply that by 47. And then that's going to round down. When we cast that back to int here. So we're going to get basically a value between 0 and 47, which is going to be a character index for when the rendering stops for that segment. So what we do is we capture the segment length then, which is going to be the next entry start, which is kind of the segment end, actually, minus the segment start. So that's going to make sense. If it's less than 1, we're going to make it 1. So we always show all the changes that we captured. And then here we actually go through all the values in the segment. And the char index here just basically determines if... Yeah, it's the character index. So we grab the value of the entry, shift it right by the bit index that we're looking at, and that with 1 and add 2, and that's going to give us either the down line or the up line here, which is going to be correct. And then, we just render the whole segment and then increase the char pointer here, and then we set the segment start to the segment end here, which could actually be this, slightly simpler. I think all that makes sense. This one that ticks really fast up here, I think that's actually wrong. Just looking at that's the drawing at Y position thing. I'm fairly certain that doesn't I think that transitions 28 times. And this is way more than that. I think it's actually wrong in this emulator, but we'll have to see. But with some minor changes, looks like this is actually somewhat different now in Manafin. By the way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, this is actually interesting because, first of all, this actually looks a lot different than what we saw in Manafin previously. And I wonder what we changed here, but like now we actually see this drawing Y match stuff is counting up. Let me actually run this in Rush Boy. Because it looks like we've fixed the code so that we see the same bug. which is definitely progress. I'll have to do a git diff and see what we actually changed. Sorry, I'm not reading the chat for a sec because I'm kind of getting in the zone here. So yeah, if I miss your message, I apologize. I need a couple terminals here. What did we actually change here? Ew, I hate when I have these new lines here. Those just plague my existence. I think it was that one we actually added. So really all we did we removed a couple things that we didn't need. We reset the interrupt clear stuff a little bit differently. White space, just screw it. We're resetting this at a slightly different time now. We look for the interrupt pending one when we actually need it. Couple small clarifications here. And that's about it, actually. Ooh, wait a minute. This actually is wrong, I just realized at the end here. We don't want to just set this to the next entry start because we cap the segment length at 1 always. That might be something interesting, actually. Let me see if this changes it, actually. Okay, we get basically the same thing here. Is that stretched out a little bit now? Did that change? Because I like this logic better, and I'll kind of explain why. Okay, yeah, so these actually got closer together here. The reason why is because if we do change this, if we say next entry start, then that doesn't take into account where we had the minimum segment length, and we actually want to do that so that we don't miss anything that we captured. So we do want this here. Let's see what Reality Boy does. Yeah, this still looks about the same. Let me get this in Rustral Boy. Okay, this looks a lot more like what we expected, by the way. And here we're also getting extra data down here. So if that's the case, then it actually might make sense that we're just drawing past the end here. I'm going to run this on hardware again, and then we might have to scale this down or something in order to fix this. But yeah, I think this is actually good that this is so much different. And in fact, if we compare this with, for example, the bits that we're actually watching here, we get drawing at Y position, which only matches once in my emulator, but that could actually make sense because the way it draws blocks, I think that's actually correct. And then we'll get the current Y position, which will basically scan out 5 bits of data. And you can see we can't actually see where this one goes high. And then we have the drawing exceeds frame period, which will never happen. And here we have the different writing to frame buffer ones, and we would actually expect it to go to one of these. So this actually looks a lot better. And then we're going to have drawing is enabled. Did I do that correctly? 1, 12, 11, 10, 9, 8, 4, 3, 2, 1. And then we actually have a few rows here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 rows. Dark says plus equals, right? Yep. Definitely. Good call. Let's run that in these emulators as well. And I think we're still getting another row down there. Oh, hey, look at this. This looks a little bit better, maybe. A bit surprised here, actually, because this is kind of what I expected the output to look like, actually, but why does this go all the way out here and then change? Perhaps there's a 0 bit here for this one, which is, what bit was that again? Drawing is enabled. That shouldn't actually change. Something changes out here, and I don't know if we write the final value for the last segment. I don't think I do that. Maybe I should. We would hit the max if on the hardware and not the emulator if the bits changed differently. Like if we captured that many. I don't think it would be. It could be the CPU running faster. It could also just be the state changing more often, which is what I would more expect. Yeah, just to use this is different bits of different registers that we're watching. This is the drawing status register. I think though that this is sort of stretched out here, and this gets kind of cut off because at the end, yeah. So like here, we get this state that comes up here, and then that goes until this is another change, and then this hasn't changed yet. So this, like these two bits here, may not actually be to scale in terms of the time, but it shows us both transitions, which is really important. And then this shows all the transitions as it counts up this value, which is all 5 bits. So this should actually count to 28, if I recall correctly. And I believe it does, because this is we can figure it out this way. So this is going to be 16 plus 8, which is 24, plus 2, which is 26, plus 27. And that actually makes sense because it's going to be 0 to 27. So this actually is scanning out how I would expect this value to do it. And then we're going to get this drawing at Y position while it's drawing this first part, because that's going to be set to 0 initially, which is, yeah, I think looks pretty good. I think this is making sense. And it's writing to either frame buffer here. Somewhat interesting that seems to flicker, actually. I don't know how you say that name, but thanks for the follow. Because I would have expected it to spend like half of its time drawing one, half its time drawing the other. Now it looks like it's alternating which one it's actually drawing. It's a bit strange. But we do actually get to where we can see the end here, and that is what we wanted to see. For a little sanity check, let's do this. Let's take this. So currently we're getting the drawing status. If we change this to the display status, we should get something pretty close to what we had previously. That's not good. Kind of. Oh, no, we're watching different bits. So that actually could make total sense. So we have to change that as well, but I do want to change this to try this. So we're going to basically get 10 through 1. I'm changing it here instead of in the loop because this is more straightforward. This flickering is what I would have expected. The timing for the other stuff is a bit different. But actually, I think this is correct with what we saw previously. In fact, if I go ahead and stash this, and then I think I had different branches for the different things, then this will look a bit different, but mostly the same. Yeah, okay. So that actually is good. That is basically the same. Yet we seem to have fixed the other problem. So if we put this back, or we can just undo this actually. Oh no, we can't do that because it reloaded, but that's fine. Oops, we do want to look at where the drawing state is because it's the initial reg value and then the other captures. Actually, we want this here. I think this is making sense. Still not quite like I expected because there must be another value here. One of these bits must change out here, and that's why this is happening. But I think that's fine. Let's try and run this on the hardware. See what we get. Just to be sure this updated. I'm going to run the padded file in my emulator. Yeah, it looks good. So I'm not entirely sure how we fix this bug. I'll do another git diff while we're waiting here, actually. But maybe it's how we're clearing it, I think is the main difference. Which maybe changes the scale. I'm not actually sure. We're doing a lot less reads on the inner pending register, so maybe that allows us to see more changes. We also reset it differently before we start capturing stuff. So I'm not really sure why this fixes that, to be perfectly honest. But it looks correct to me now. So that says something at least. I fixed that little white space thing. Wow, Victor 1605. Thanks for the follow. And again, I do want to actually run this. If this looks sane on the hardware, I do want to run the other ones as well. Again, just to make sure we get the right data. But I have a good feeling about this. So we got the extra row thing again, which is annoying. And it fills up and then we get a red screen again. And it also, there's a lot of jitter that I can see with capturing the values, which is somewhat interesting. I'll get to that in a sec. So it's still interesting that the row below it like fills up. And I wonder if like... So first of all, I never clear it. I never clear the screen each frame. We could try to do that, which would at least remove those sort of overflows over time. Because the thing is, if we got like a bunch of entries, like way more than we expect, and then we go ahead and render that, that would stick around. And so as it fills up, that could just be that we get more and more over time, which I'm still a bit surprised about that, but it is possible that we're just getting that many state changes that we're able to capture. It looks like the bits that I'm seeing before that happens are correct. I mean, I'm not showing it to you guys because it really just looks like this, except that there's another row here that like fills up and then it just goes solid red. Also, this seems to be a lot more stretched out. I think one of these emulators actually showed it kind of what it looks like. Yeah, it looks a lot like this, but these jitter so much. They just move around all the time. So it could be something really interesting there. But let me actually increase the max entries here just to see if we still hit that on the hardware. 1,000 is going to be a lot of these. But maybe that's fine. If it takes us too long to render stuff, that's actually, it should be okay. This was interesting too, actually. Wait a minute. Wait a second. Hold up. It actually looks like the amount of entries that I did changes this. Something's weird here. Fairly stable as it scans out these values here. Retro Boy should look like we've seen here. But if I change this to 1,000, just the max entries, looks the same here. But in Retro Boy, it actually looks like this now. The really weird thing about this actually is that just now when I was sitting there on the hardware, I kind of reset a few times, and one of the times it looked like this, and I just reset it and it was back to how it was before. That's a bit interesting. Let me see if just changing this value gives us sort of different results here. 200 doesn't like. Oh yeah, I'm not rebuilding. When testing with Boy, I gotta build here. So 200 we're fine with. Let's binary search this. 500 we're okay with. Try 750. 750 it's okay with. Try something like 800. We'll do 900 just to bump us up that direction. And then bang. Around there it breaks. That is really strange. Seem to be okay with 800. Now I wonder if it just lays it out in memory in a weird place. I hadn't actually tried to calculate how much memory this is. So it's going to be, in this case, 6 bytes by 800. Which is, yeah, only like 5K. We should have a lot more memory than that. So it's a bit odd. I keep the old data, Dark Second, but I reset the amount of entries. So it should be fine. I reset the num entries before we do this. Every time I capture. So it should be fine if we're doing stale data because we overwrite it every time. The struct might get padded. That is a good point. If this gets padded, then it would be probably on word boundaries. And that would mean that instead of being 6 bytes, it's going to be 8. Still, though, only like 6K. And then, yeah, 8 by 8 or 8 by 1,000. Still only 8,000, which is less than 8K, and we should have 64K of memory. It's a bit odd. But just to see what happens, I'm going to try to run this on the hardware. So even if it got padded to something ridiculous like 16 bytes, we'd still be well within our limits, even if it were 32 bytes. We would still be fine. Because we basically don't use any RAM for anything else except just stuff on the stack. The standard library might have stuff in there, of course, but I don't think it's going to be that much stuff. 40 emulator streams, you guys. That's pretty sick. Yeah, I'm thinking if I increase this enough, like if there's a lot of jitter, then we actually might be recording that many entries. 800 is going to be a lot, though. Thanks, Mad Moose. I guess it's possible, and that's also why I want to try doing this, but it feels a little skeevy. But it especially makes sense because like when we start the capture, there's going to be some jitter. Yeah, that's a good idea, Duro. It's to do overflow detection that way. That's a good idea. Okay, now it just looks really good. So I think the only reason why, I think that's definitely overflow that we see on the bottom, and I think the only reason why we see that on the last one, the only reason why we see it on the last one is because, like we render bit by bit, and we render the first one first, so that's going to overflow into the second row, but then we're going to overwrite that with the second row's data. So that would cause the rendering that we see here. So to give you an idea what this looks like, it basically looks almost exactly like the Reality Boy one, actually. So just going to run that really quick. It basically looks like this, except with a shit ton of jitter. Also, it looks like all the bits here are set initially, which might mean like it holds the value at the end of the last frame just until it's used again, which is kind of interesting. I'm going to have to get a video of this one because seeing all the jitter is actually really cool. But I think from seeing this and seeing how much it matches what we expect, I think this is correct now. And then we got to figure out a way to render it with more resolution. I think I have an idea for how to do that. So I'm gonna be right back, and then we'll dig into that a bit. And I'm back. Initially, something that I actually want to point out, this is actually really interesting, is this first bit here. I was just thinking about this. And let me pull up the spec again here. So one of these is the drawing at Y position. And what that does is, as it's drawing, I believe it draws the screen in a bunch of columns. And this will basically fire every time that the there's a Y position, that the current Y position, which is where it's drawing to, matches a Y position that's in some register. I don't remember where that is. But the idea is that this is actually going to fire every time it hits that, not just once, which is what our video hardware thinks it'll do. So we only get one blip here. But Reality Boy seems to be doing this, at least it looks like it's correct, because the hardware definitely fires this many times on this bit. I actually wonder if we can take kind of a shortcut here and remove this bit just to see if suddenly the rest of them will all fit. Now I'm going to do this sort of as a comment here because I want to remember specifically that we're doing this. And we'll see this in Reality Boy, and at least the state changes slower. Although I think we're still capturing that bit, so hold on. We need to chop off the bit here. In fact, actually, let's do this. Let's put this back. And then we'll chop off the bit when we capture it. And that'll be EF. Here and here. And that should squash this quite a bit. That didn't look like how I expected. It's 7F, not EF. Whoops. The other one. Or, it's still not. It's 7FFF. Jeez. This guy. All right, so here we see it scan out. And then it holds a while until we get this. So here we actually even see Reality Boy emulating this, that this value is held the whole time, which looks like the hardware's doing that as well. That's pretty cool. That is a cute trick, Dana Colin. So this is interesting. This would allow us to sort of fit everything on here, and then we'll just miss the fact that the drawing at Y position is just flickering all the time, which might be enough. So I actually want to run this on the hardware again. What I was thinking about for getting high resolution is that I could split the characters so that we have basically 4 versions of the on one, where we can split it into 4 pixels and 4 pixels instead of an 8-pixel block, and that would give us twice the horizontal resolution at the expense of very slightly more complicated rendering, which wouldn't be too bad, I think. But I think this would be a better shortcut, and I would feel a bit better about doing it this way, if this gives us what we need in the emulator. And then we can basically write down in our notes that the top bit actually flickers a bunch, which I think is going to be accurate enough for what we're trying to capture here. Interestingly enough, it now basically matches this, which is actually exactly what we would have expected then if that bit is not firing all the time. So that's actually pretty cool. Let's wait for that. But at least it looks like the drawing, the extra row that we saw was just drawing extra bits because we captured so many entries. And it looks like we captured that many entries because this drawing at Y position thing appears to happen a ton of times. Should actually measure how many times per Y value it hits. That could be somewhat interesting. Oh, beautiful. Now this looks really good. Yeah, I'm just going to get a picture of this now. I think this will more or less give us what we need. Making the rows slightly shorter also really helped here. This actually looks a lot like Rush Duel Boy now. Yeah, if that would require at least a LLVM backend. But could use the binutils patches in the GCC VB package. Those should actually still work. That would at least give you that support on MinGW. So that is uploading to my Google Drive, so we'll get it in a second. And while that's happening, I'm just going to do actually one more capture of this where we don't mask off this bit again. Because I wanted to see how many state changes this goes through, this top one here. Basically how many we can capture within these, how many it looks like it happens on the hardware. We're probably going to miss a bunch depending on how this ends up firing on the hardware. But I would just like to see that. I might as well get pictures of both, or pictures of that first one and then a video of this other one. Yeah, that's the way to do it, man. Moves. There's also like the standard library stuff that would have to be done there. At least bare metal rust wouldn't be the most difficult thing. You need a bunch of like crazy stuff though. Like in order to support F64s, you would need to do that in software. So I'm sure there's just a ton of stuff that you wouldn't think about that you would need in there, but in theory, it's doable. Just like a mountain of work for very little gain. When just writing this stuff in C is actually quite natural. On this episode of Ferris Sits Patiently. By the way, I bought Nier Automata today for my PS4 that I bought last week. I'm looking forward to that tonight. Yeah, I gotta get a video of this. The jitter here is just really interesting. Oh, wow. This video has really good frame rate, actually. Yeah, by the way, I think it was Richard Hutchinson who sent me this flashcard. I know I give him a shout out like every other week for this flashcard, but seriously, thank you so much. This was actually really cool. Yeah, thank you, Rich. It's been so good to test this stuff on hardware. So first of all, it's September now, right? It is. Here we go. Here's the first picture I got. You can see this looks a lot like Rush Boy. A couple things to note here, though. Particularly, this... Here, I'll run Rush Boy again. It's really interesting that these flicker. I did not expect that at all. I need to look at the code to see if it alternates which frame buffer it draws to, because it's actually pretty interesting. But it does scan out the Y values like we would have expected. This basically looks like what we would have expected, except this one bit here, but that's because we don't capture it here. So that actually kind of makes sense. But yeah, I mean, the timing here actually looks pretty good in terms of when it actually changes all these states and then whatever it waits till for it to stop capturing. And then also this here, it holds that value until the next one. You can see here, these bits are already set before this starts. They get cleared some other time on the left here. And it looked like Reality Boy basically had that right. Let me sort of fix this here. So yeah, we don't see where they transition that state, but yeah, it definitely holds the value, which is somewhat interesting. Nice, baggers. I doubt holding the value would make much of a difference, but we should totally emulate it because it would be a really easy thing to emulate and a really easy thing to test right now. So that's actually pretty cool. But yeah, they didn't get this right though. These two bits here, which is the drawing to whichever frame buffer bits. But I mean, overall, this looks pretty good. And ironically, Rush Boy gets that right. And I am probably just forgetting some details of something, but that seems to be implemented at least correctly against the hardware, which is pretty cool. And now it looks like we got that video. I just want you guys to see this jitter. It's really cool. Let me pull this up and you'll see. I mean, I need to like crop these videos, but this will be good enough to see. So this is how much it jitters on the hardware. Just showing you how kind of crazy this is. These bottom ones, you can't actually see them in this cap. They're actually down here. You can actually see them flicker a bit. Oh, wait a minute. Oh, this is actually really cool. Hold up. Okay, I don't know if you guys can see this sort of darker bar here. But there's something really cool happening. Something really cool. It looks like, because here's the thing, these two bars here, they just flicker on and off. Like when you look at it in the hardware, it's very clear that that's what's happening. As I slow this down, you can see it kind of scans out those values. I was thinking, oh wait, here it changes like halfway through. But then I looked a bit closer and it always matches this red line here. So what I think this red line is, I think this is the video hardware scanning out that pixel for the next frame onto the sensor here. And I guess we captured this because the camera was at such a high frame rate, which could make sense because the Virtual Boy runs at 50 FPS, but if the camera were to capture at 60, we could see this. And I think we're just seeing the transitions. Like here's a really beautiful example of that where we see the dark bar here and here, probably as it's going to scan out. And here we see the changes on both edges there, where it was going to be changing from this one being on to this one being on. So that's actually really sick. I did not expect to see that. But I mean, this is what it looks like on the hardware, except for that these are on or off, just solid, according to the eyes. I should actually try an iPhone at 240 hertz, but I don't have my iPhone with me. Metal voids, it's like those nerds in the movies just interpreting numbers and stuff. Exactly. I'm happy to be one of those nerds, especially if it's Revenge of the Nerds. Oh, God, that movie's terrible. But this was really cool. And that's basically... Didn't expect to be able to see those transitions, but basically what we're seeing on the hardware does match. You can see you can see here too. You can kind of see where that bar was here. That's so rad. But this does actually match hardware pretty closely, except of course that whoops, didn't mean to close a terminal over there. Except that very top bar, which we've removed in some of these captures. Yeah, just running this again, or just not the pad one. There we go. But yeah, again, comparing these two, looks pretty good. Yeah, Studio C, that's what I got in my head as well when I mentioned the movie. It's so awful. But this is really good news, other than the fact that it holds this value. This basically matches. And that Y matches thing. We need to make that bit go nuts. So, interestingly enough, now I kind of want to just put this in context here. Assuming that these would match up here. Particularly, I'm hoping... Okay, start of drawing hits here. We do actually have drawing finished, which is over here. And it's kind of weird that that happens like here in the frame. But you know what I think is actually happening here due to the way we're capturing? This has to count out this many bits, again, because of how we drew this. And I'm wondering if the drawing finished here actually would correspond with this drawing finished here. It's also interesting that the Y position match only happened twice here. I wonder if we just missed all the other ones or if something else is going on there. I think we may want to look at this register again. But I would not be surprised if this were stretched out and then the value that we saw here was actually this one. And then we see all that area on the right. Just because it would have been basically blank till the end, but then all that gets stretched out, which that would make sense with the rendering that we have. And then at least we would be able to see that correlation, and that's pretty cool. I don't think holding these values would actually fix the thing that we're seeing. Because the rest of our timing is a bit wrong as well. I really think fixing the timing is going to do it. I do want to fix this as well. But I think we'll want to fix both. A bogus cap for my pirate. I'm sorry, I find that really funny. Shout out to Alkama for just totally derailing anything that looked like a train of thought that I had before that. It's just goofy. I'm sorry. Oh, I don't know why I found that funny, but that was really great. No. Do not be sorry, Alkama. In fact, thank you for that. I needed a good laugh. Pirates do have bogus caps. That's why that's so funny to me. It's just Colin, bugfix will now take 5 episodes longer. It probably will. I'll be laughing about this next week. It'll be like this, you guys. Like that. Like I'll just start the stream laughing. By the way, speaking of just laughing, I keep forgetting to like find a place to do this in the stream. But this is me being PewDiePie. And I just think it's really funny that I can just zoom in. Anyway. I've been waiting for a good time to use that, but yeah, it'll happen when you guys least expect it. Squirrel music. Yeah, exactly, Alkama. It's like as soon as we fix this bug. Hold on, I gotta open it up again. As soon as we fix this bug, it'll be like, oh! Wait, I need more zoom. Whoa! Whoa! Okay. I'm sorry, I'm in a good mood. Because this is actually really good. I think we fixed the problem for the cap here. And it still looks like the rest of the caps are correct. Might want to do them again just in case, but I actually want to run with this because, again, all I really wanted to see is does this make sense? And it looks like it does. Now, it's still really interesting, though, that the drawing status thing fired so many times, but the Y position match in the interrupt pending register didn't, so maybe we'll want to recap that. Sorry, Daru. Now I'm all giggly. Let's do that really quick though. Because now I've gotten pictures of this at least, and I can sort of organize those in a sec. Let's just recap the interrupt pending stuff. We should still see the correlation here. This should basically it should look the same with this fix. So we'll do that. And And here, all I'm going to do is just swap this out here. And then the different bits that we need to watch. I think there was a different number of bits as well. I think there were only 8 of them. $15, $14, $13, 4, 3, 2, 1, 0. Just thinking of how pirates have bogus caps. That's just find that so funny. Just, I don't know if it's the word bogus or what. This sucks. This is not supposed to be this different. What did I mess up? What did I screw up, guys? Oh yeah, first off, we have to write it back. Let me just do this. Why is that so different? I don't like that that's so different. Although we do still get the left finished and right finished happening in what looks to be kind of sane in relation to each other. But it looks like the timing for Y position matched and drawing finished has completely changed. However, drawing finished maybe makes sense here. Let's see what this looks like with the display status here as well. Or actually, let's run this on hardware while we're still looking at this one register. I don't know why that changed so much, but if it allows us to see more correlations, I'm okay with it. For example, if we just run this now here and look at some of the previous stuff we had. Where did I put those pictures here? Again, this was not the one we wanted to look at, actually. Do the video again. No, that also wasn't the one I wanted. Did I not take a picture of the last one? No, this was the one. This was the one. It's interesting that this interrupt only fires once, but then the value actually matches several times. That's pretty interesting. Wonder why that happens. Maybe it fires. No, that can't be it. It's weird how the drawing finishes and then the display finishes, then the display finishes like really in quick succession. Yeah, sorry, Sudusi. We might be a little screwed here by scaling things the way we're doing it. But I just want to see. Okay, there's way too much variance here on the hardware for me to be comfortable. Like this is straight up weird. Let me just, as a test here, just to be quick, do this again here with the drawing status. And I realize that I'm getting a little bit messy here. But I'm just really interested in this right now. Yeah, again, just 10 through 1. Okay, so we're back on this, which still looks like what we would have expected. I'll run this on the hardware too. I probably should have. No, wait. Okay, good. Okay. So that basically matched what we had on the hardware from previously, which is good, I guess. Basically have the same exact thing. But this one sometimes looked like this, and sometimes it looked wildly different. So I need to get a video of that. And then it looks like we got a good video of this. So let me get a video of this one again, and then I can sort of show that. And I think I'm gonna stop the stream there. And we'll have a think about this. Actually, we'll do it this way, I think. Yeah, that was the drawing status. Yeah, that's correct. It's not. Because I mixed up these two, I think. Or, yeah, I think I did this wrong. I should just check the values. Because I want to have that in the other order. Well, I'll just sit in here working with this. But this should be the drawing status for sure. And this will be the display status. Did I just not rebuild that, or this does not look correct to me? Ugh. Okay, so display status was this one. Oops. So this is the interdepending one. And this is display status, so it should look like that. And then we need the back up to 10 bits again, which we're fine here. Subset rebuild. Come on. Oh, no, that is actually correct. That's what we wanted here. Then I was going to change this back to interrupt pending. That's what I wanted to do. That's what I wanted to do. This is why I need to cut off the stream pretty quick here, because I'm getting quite tired quite fast. I'm actually on like human being sleep schedule last few weeks. That means I actually get tired in the evening. Yeah, so this sort of sparse thing is more or less what we expected here. And then we'll do this. I gotta say, I'm quite impressed with the quality of Reality Boy, at least in terms of its video hardware emulation. They must have really done a lot of these kind of tests. Not necessarily exactly like this, but a lot more rigorous testing than Mednafen, at least. Because we're seeing it seems to be a lot more accurate to the hardware, at least in this regard. I just realized something else. The different bits in our capture are not actually going to be to scale necessarily. For example, if one of the bits is changing really often, like this. If one of the bits is changing really often, then that one bit will get stretched based on how we handle the segments, because we do the segment stretching per bit. So we actually need to invert this loop. I should actually really do that before I forget. Yeah, Cluash. We definitely need that. and a bunch of the ones with me just looking into the Virtual Boy. Those would be good. Yeah, this is bouncing around like I expected. But I gotta be honest. The realization I've just made is really bugging me. So I need to fix that now before we move on. So let's get we'll do this on the drawing status, because that's the one that had a lot of changes. So we'll do that again. And I actually don't want to mask off this other bit here. Like that. Because I want to see that these changes happen. Because what I'm basically saying is that this will scale up this row here. It won't necessarily scale up the other ones, I think. Oh, wait, you know what? No, I'm wrong. It totally will, because we do this for every entry, regardless of whether or not the entry actually changed values. Never mind. We're totally okay. Okay. We're totally fine. We did this right. This is the other reason I need to leave soon, because as you can see, I'm quickly deteriorating. But I want to get a video of this current hardware test. And then we'll call it a night. This stuff has been a bit slow and tedious, but we're getting really good info here. So even though we're not making that much concrete progress, I feel really satisfied after these last couple streams. Though there's something very strange going on here. T-Bot, no, this is a Virtual Boy emulator in Rust, but this is a hardware test we're running in C. It's a C89 specifically. It's the right tool for the job. I'm just gonna wait for this to transfer here. Okay, that's up. Now we gotta wait for it to come down. I'm not actually sure why it's jittering, why this one changes so much on the hardware. It's a bit concerning, but we'll see. And it has arrived. I need to pull this up in VLC because I have a lot easier to zoom in and stuff here. You can see me in the background. So it's weird because this jumps around quite a bit. We see some of the same structures here, though, like this pattern here and also this pattern here. But they seem to like bounce back and forth across the frame. Like sometimes we'll get this. Another time we'll get like just none of them or different things. Like it seems like it's the same bit pattern. It's just kind of offset in different places. Now, I actually would have expected to see something like this where we see it twice because I would have expected the left and the right to have happened. So the fact that we see a couple frames like that might be a little reassuring. And maybe it's just not necessarily scheduled with the start of the frame. Not really sure why this is happening. Should probably take a bunch of pictures at some point as well, just so that we don't get the frame blending. Or at least it wouldn't be as obvious. But yeah, it's a bit odd how much this changes. Which is really weird too, because we're watching this exact same start and end bits for when we start and end the capture, so I'm not really sure why that is. But I think I'm going to cut off the stream now. We'll give this a bit of a think before next week, and then next week we'll hopefully have some more information and finally start digging into actually matching this timing, as well as implementing the hold of the like the additional details about the Y position matches whatever, both the status bits in the drawing status and also the interrupt. So yeah, that should be fairly interesting. But anyway, thanks guys for hanging out, and I will see you next time. By the way, tomorrow might be a stream from the Fuse office during work hours CEST. Not sure when that is. That's why I just keep saying work hours. Depends on a lot of things, and I may not do it, but stay tuned for that. I'll let you guys know on Twitter. And then back to Demo Scene stream on Sunday. But yeah, again, thanks guys for hanging out, and I'll see you next time.